The world offers an overwhelming number of substances. To bring order to the system, chemists develop the periodic table of elements in increasing order of their atomic number. In this video lesson, we will trace the development of the periodic table from observations based from the properties of elements. Specifically, we will explain the trends in the periodic table to predict the chemical behavior of an element. The periodic table presents the elements in systematic and organized manner by arranging them in order of increasing atomic number and recurring chemical properties. By looking at the periodic table, you can see that the elements are arranged vertically, which is called groups or families. The elements in each column have similar chemical properties due to their similarities in the number of electrons in their outer shells, or what we call as the valence electrons. The periodic table of elements have 18 vertical columns. The elements are classified into two categories, namely Family A or representative elements and Family B or transition metals. The first group is called the alkali metals. This group is composed of lithium, sodium, potassium, rubidium, cesium, and francium. All the elements found in this group are highly reactive in nature and are soft solids. The second group is called the alkaline earth metals. They are composed of beryllium, magnesium, calcium, strontium, barium, and radium. They have high reactivity with oxygen, which leads to tarnishing. They also form good alloys, which are used by the automobile and aviation industries. The boron group is composed of boron, aluminum, gallium, indium, thallium, and nihonium. Members of this group are preferred to be in alloy form as its pure form is normally weaker than the other metals. The carbon group is composed of carbon, silicon, germanium, tin, lead, and flerovium. The most prominent element in this group is carbon due to its infinite application to any industry. Elements from group 5A are also classified as the members of the nitrogen groups. It is composed of nitrogen, phosphorus, arsenic, antimony, bismuth, and moscovium. Nitrogen by itself is an important element for fertilizers, nylon production, and dyes. The chalcogen group. It is composed of oxygen, sulfur, selenium, tellurium, polonium, and livermorium. The most prominent element is oxygen. It is a fixture for living organisms to maintain life. Except for oxygen, most elements in the chalcogen group naturally exist as solids. Applications of chalcogens include sulfur for detergents and selenium for solar cells. Halogen group. This group is composed of nonmetals which can easily react with alkali metals. Noble gases is composed of helium, neon, argon, krypton, xenon, radon, and oganesson. They are also referred to as inert gases because of their non-reactivity to many elements. Elements under the D block are transition metals. They exhibit the usual properties of metals: hard, malleable, ductile, and good conductors of heat and electricity. They also have very high boiling and melting points. Because of these properties, transition metals such as titanium, copper, and iron are preferred by heavy-duty industries such as shipbuilding, construction, and automobile. Elements under the F block are collectively known as the inner transition metals. It is composed of elements under lanthanides and actinides group. The periodic table has 7 horizontal rows called periods. Period refers to the distance of the electron from the nucleus. It is also known as the shell. The last cluster of elements are called blocks. Blocks are best imagined as Tetris parts with 4 different kinds. The S block is composed of the first 2 columns of the table. The D block forms a rectangle that starts from period 3B until period 2B. The P block comprises the group 3A to 8A, while the F block is the extended rectangle below the main table. The properties of elements vary within group and across the period. The periodic table will help us in predicting the properties of elements. The atomic size corresponds to the radius of an atom of an element, or 1/2 the distance between 2 nuclei of 2 adjacent atoms. The atomic size decreases from left to right and increases from top to bottom of the periodic table. Ionization energy refers to the minimum energy required to remove an electron from an atom in its ground state. Ionization energy increases as atoms become smaller because, in this case, electrons are more attracted to the nucleus. Ionization energy increases from left to right and decreases from top to bottom of the periodic table. Electron affinity refers to the measures of atoms' ability to attract electrons towards it. Electron affinity depends upon the electron configuration of the elements. Electron affinity increases from left to right and decreases from top to bottom of the periodic table. Electronegativity. It is the capacity of an atom to grab an electron in a chemical bond. The greater the electronegativity, the greater the attraction for electrons. It increases from left to right and decreases from top to bottom of the periodic table. Atoms are classified as metals if their outer energy levels have 3 or less electrons, while those with 5 electrons or more are considered as non-metals. Metallic property is the ability of atoms to lose electrons, while non-metallic property is the ability of atoms to gain or accept electrons. Metallic property decreases from left to right and increases from top to bottom of the periodic table. The periodic table will help us in predicting the properties of elements that are not directly visible, such as atomic radius, ionization energy, electron affinity, electronegativity, and metallic and non-metallic properties. Now, let's check your understanding. Arrange the numbers of each of the listed element groups in increasing order with reference to the property indicated in each column. If you like more science videos, make sure to subscribe to this channel. Thank you, and always remember that you are all awesome.